Alright, this is where we left off in the last video. Let's just erase these things. We looked at the order of the differential equation, and we saw that where it has a dy by dx, it's a first order. But if it has a d square y by dx square, even if it had a dy by dx also, it would be a second order differential equation. Now, we want to see how you might form a differential equation. Suppose you have y equals, say, a number, say 4 sine x plus 6 cosine x, right? And here we can see two constants. They call them arbitrary constant. They can, well, in this case you have specific numbers. If it was a sine x plus b cosine x, these would be arbitrary because they could be any number you want. But in this case, what we have are constants, specific constants, 4 and 6. But anyway, we want to form a differential equation from this equation. So let's differentiate. dy by dx is equal to, when you differentiate sine, what do you get? You get cosine. So you have 4 cos x. Then when you differentiate cos, you remember what you get? You get negative sine. You say minus 6 sine x. Good. Now, suppose you differentiate again. You say d square y by dx squared equals, alright. When you differentiate cos, you get negative sine. Negative 4 sine x. Then when you differentiate sine, you get positive cosine. So this sine, this minus remains, it will not be affected because it's a positive that you get when you differentiate sine. So you have 6 cosine x. Let's fix this up a bit. You have d square y by dx squared equal, let's put a negative outside, negative and bracket 4 sine x plus 6 cos x. Alright. Now, let's look at this. This is a 4 sine x plus 6 cos x. But it's a negative 4 sine x plus 6 cos x. And remember, you see the 4 sine x plus 6 cos x here? It is y. So you could say that what you have is d square y by dx squared is equal to negative y. Alright? So here we have our differential equation. And we could rewrite it and say the differential equation we formed, this should be square now, is d square y by dx squared plus y equals 0. Alright. And you know the order of this differential equation, it is of the second order because we have d square y by dx squared. Alright? That's of the second order. So we formed the differential equation from y equal 4 sine x plus 6 cosine x. Alright? Now, let's look at another one. Suppose we have y equals, say, x plus, let us say, 2 over x. Y equals x plus 2 over x. We want to form a differential equation. So we differentiate dy by dx equals. Now, when you differentiate x, what do you get? You get 1. You have to remember the power rule, you know, at this stage. Right? You have to remember them by heart. Plus, when you differentiate 2 over x, what do you get? Well, 2 over x, just do a little rough work at the side here. 2 over x is 2x to the negative. My, let me rewrite that. It's 2x to the negative 1. Alright? Remember your indices. Multiply by the power, negative 1 times 2x to the, reduce the old power by 1 to get the new power. So what it is, really, is negative 2x to the negative 2. And the thing is, negative 2x to the negative 2 is negative 2 over x squared. Right? So you could just write this as 1 minus 2 divided by x squared. You see that? Now, here, let us fix this up. This 2 over x that we have, what we're going to do, right, is rewrite this as dy by dx plus 2 over x squared plus 1 equals 0. So that's what we have. Well, this seems to be our differential equation, but let us redo this using an arbitrary constant instead of a specific constant. What we're going to have is, say, could use a letter, say a constant. Well, we usually use C. Alright, let's just use A, the letter A, over X, right? And we're going to eliminate the A at some point. Differentiate. You have dy by dx is equal to, when you differentiate x with respect to x, you get 1. When you differentiate a over x with respect to x, again, this is ax to the negative 1. Differentiate it. You multiply by the power, negative 1 times ax to the negative 1 minus 1 to get a new power. So you have negative a x to the negative 2, which is the same as negative a over x squared. Remember that. Now, here, suppose you consider this a over x, right? What can you do with it? Well, you could say you transpose to make a over x be equal to a over x. You subtract x from both sides, right? So you say this is y minus x. So a over x is y minus x. And what you can do is multiply both sides by x, so you get a is equal to x times y minus x, right? So that is a, is x times y minus x. So let's rewrite this. You have dy by dx equals 1 minus what now? Remember, now this is a, but a is x times y minus x. So instead of writing back a, you put x, y minus x, alright? Over x squared. So that's what you have. Alright, let's simplify this part. How can we simplify it? Well, we have a fraction minus a fraction. So let's use common denominator. So dy by dx equals, if we have common denominators, remember out here would have an x, y minus x over x squared. So you see that we want something over x squared. right? Minus something else over x squared. So we have x squared over x squared. So you see that? Now, this is a common denominator. So what we have is everything up top over x squared. So we have x squared minus x, y minus x. That's dy by dx, right? So we continue. dy by dx equals, let's open the brackets. So we have x squared minus x times y gives us xy. Negative times negative will be a plus. X squared by x squared will be x by x, will be x squared, right? All over x squared. Now we continue. dy by dx equals. Let's factor out the x. Remember, x is a common factor. We have x here, and x here. Alright? So let's factor that out. We have x outside the bracket. And we have x minus what? Y plus x. We just divide everything by x over x squared. Now, here, what do we have? X into x one time. X into x squared goes x. So what we have is that dy by dx is equal to x plus x would give you 2x minus y over x. And then what we could have here, multiply both sides by x, we have x times dy by dx equals 2x minus y. So we have a first order differential equation involving x and y there, right? So we formed a differential equation from that original equation. Alright, let's form a few more differential equations. Let me see now. Let's erase the board. Let's keep this. I want to copy this, erase the entire board, and paste back my heading. Differential equations. And we're looking at formation of differential equations. Now, suppose we have an equation, a polynomial quadratic equation, y is equal to, we have arbitrary constants in it, ax squared plus bx. And we are going to form a differential equation without the a and the b. We don't want to show the a and the b. So, let us differentiate. dy by dx equals, this would be 2ax plus b. Alright? Should see that. Let's differentiate. Second derivative. d squared y by dx squared equals, this is going to give you 2a. And the b is a constant, so the b is gone. Alright? Now, here, d squared y by dx squared is 2a. Suppose we consider that a in this case, if we transpose this for a, transpose this equation for a, we will have a is equal to d squared by dx squared over 2. In other words, a is equal to half d squared y by dx squared. Alright. Now, this a, let's put it here and see what happens. As remember, we want to get rid of the a and the b. We have dy by dx is equal to, it was 2 times, now here we have a, so we have the x here, so we have 2a times x, let's put the a first, and then the x plus b. But remember what a is. A is half d squared by dx squared. So let's get rid of this a here, and we write 2 times half d squared y by dx squared. 2 times half is 1. Alright, so that's gone. And then what we have is dy by dx is equal to this x, let's put it in front. So we have x d squared y by dx squared plus b. Alright, so that's what we have there. Let's transpose this for b. What would we get? Well, if we subtract the x d squared by dx squared from both sides, we'd have b is equal to, going from right to left, this would be dy by dx minus x d squared y by dx squared. So that is what b is. B is all of this. Right? Now, let's look back up here. We have our b right here. So, we already substituted a in this one, the one that says dy by dx. Let us take b now and substitute it up here into y equal a x squared plus b x. Let's rewrite it. Y equal a x squared plus b x. I'm making some space between them. Now, here, you know what a is. Alright? A is half d squared y by dx squared. So, this is half d squared y by dx squared plus b now. What is b? We have it here. So, let us put b out here and the x on the left. Let's put the x here and then put our b. Let's open my bracket and put our b. dy by dx minus x d squared y by dx squared. Alright, so that is our a and our b. Let's open the bracket and see if we can do some amount of simplification and so on and so forth. Y is equal to, now this is half, let's put the x squared over here. So we have x squared over 2 d squared y by dx squared plus x dy by dx minus x squared d squared y by dx squared. Okay. Now, here, what we're going to do, this says d squared by dx squared, this says d squared by dx squared. If we should put them together, we would have half x squared d squared by dx squared minus x squared d squared by dx squared. Right? What is half x squared minus x squared? It's half minus 1. Half minus 1 is negative half. Right? It is negative half of the d squared y by dx squared. That's what it's going to amount to. You see that? So, what we have is y equal, let's put this down first, x dy by dx minus half x squared d squared y by dx squared. Right? Same as x squared over 2. Let's write it that way. X squared over 2 d squared y by dx squared. So we have y equal x dy by dx minus x squared over 2 d squared by dx squared. Alright, we got rid of the a and b, the arbitrary constants. And what we have is a second order differential equation. Right? The highest derivative is d squared y by dx squared. Alright? Alright. Now, this is a second order differential equation because we had two arbitrary constants. The first derivative, we got 2ax plus b. Second derivative, we got 2a. Alright? So we eliminated one and then we substituted. Well, you'll find generally that if you're asked to form differential equations from polynomial equations, the polynomials with one arbitrary constant will give a first order differential equation. Those with two arbitrary constants would give second order. And if we were looking at third order differential equation, they would come from those with three arbitrary constants, and so on and so forth. Alright? Now, let's just erase the board and we do a few more. Erase. Let me paste my headings back up here. Alright, so we might have a case where we say y equal ax e to the power of x. I write it so near. Let me write it further down, give the thing some space. Y equals ax e to the x. Alright? Now, suppose we say dy by dx equals. Alright, we have two functions of x here. So we can use the product rule. We have ax and we have e to the x. Alright? So we hold ax as it is, ax, differentiate e to the x, we just get e to the x. Plus, hold e to the x as it is, times, differentiate ax, we get a. Right? So, remember the product rule. So now, what we have here is that dy by dx equals, we differentiate, what we get is a e to the x, and then we're going to have x plus 1 here. Alright? Now, we want to get rid of the a. So, let us transpose to make a the subject. A would be equal to dy by dx all over e to the x times x plus 1. Now, a is this. So y equals a, which is dy by dx all over e to the x times x plus 1 times e to the x. Now, we want to fix this thing up, right? We have e to the x will cancel e to the x. So what we will have here is y equals dy by dx over x plus 1. right? Let us multiply both sides by x plus 1. We're going to get y times x plus 1 equals dy by dx, right? Now, what we can do is open the bracket. Let's open the bracket. And we have xy plus y equals dy by dx, right? Now, in this case, hold on, let's look back up here. Let me see, just review it. X, e to the x, e to the x, x times plus 1, e to the x, good. We have x here. Then e to the x multiply, have e to the x, and the e to the x is gone, eliminated. So we have x y plus 1 equals dy by dx, good. Oh, okay. So dy by dx in this case, let's not open the bracket just yet. We have dy by dx would be equal to, and then y x plus 1. All right. Now let's just review. So we have ax e to the x. We hold ax, differentiate e to the x, good, plus we have e to the x, differentiate ax. I'll get this. So here now it is equal to, we factorize and we get a e to the x, a e to the x, x plus 1. So we have a is equal to dy by dx over e to the x, x plus 1. And then we say y is equal to ax. Oh, guess what? I left out the x. It is a times x, and x should be here. My. I was wondering if something was left out, Is a times x. So it's a times x times e to the x. So it's a is all of this, times x times e to the x. Okay, good. Okay, so we had left out the x. My mistake there. So it's x. So we multiply x plus 1 times y. And we have dy by dx times x. And then when we switch the dy by dx x over to the left, we say x dy by dx is equal to y x plus 1. Alright? What we could do is say x dy by dx. Subtract y x plus 1 from both sides. So we have minus y x plus 1 equals 0. So we have our differential equation there. Alright, I'll see you in the next video.